In this video, we'll be handling a slightly more difficult problem. This time we'll be solving for the sequence of x of k is equal to k times 3 raised to the negative absolute value of k. We will only be solving this one with the analysis equation method. Once again, the analysis equation is shown in the top right corner of the screen for a reminder for you. And now, in the first step of our problem, we're going to be plugging in our x of k to the analysis equation. Alright, now we move on to our next task of removing the absolute value of k. We do this by splitting it into two summations, where the first summation is negative infinity to negative 1 of k times 3 raised to the k times e raised to the negative j omega k plus the summation of 1 to infinity of k times 3 to the negative k raised to the negative k times e to the negative j omega k. Notice in the summations there are no 0 because when k is 0, it is adding 0 to the summation. Next we will multiply the first summation by negative 1 so that we get the negative summation of 1 to infinity is k times 3 to the negative k times e to the j omega k plus the summation of 1 to infinity of k times 3 raised to the negative k times e to the negative j omega k. From here we will combine the three negative k's to their exponential table, yielding the following summation of 1 to infinity of k times 1/3 times e raised to the negative j omega, where that sequence is raised to the k, minus omega minus the summation of 1 to infinity of k times 1/3 e to the j omega with all that raised to the k besides the k. If you haven't guessed yet, all the rearranging is to get the summation in a form we can use as a summation property on such as the summation property of summation of 1 to infinity of k times a raised to the k is equal to a over parentheses 1 minus a squared. This yields from our following summations that 1/3 e to the negative j omega over parentheses 1 minus 1/3 e to the negative j omega all squared, and minus 1/3 e to the j omega over parentheses 1 minus 1/3 e raised to the j omega, all of that squared. From here we find the common denominators and subtract. That may have seemed long, but the next step will be even longer, unfortunately. we will then FOIL the top parentheses and the bottom two together. Please hold while we write this equation out. Next, we will combine like terms. Also, I want to note, as we combine the steps of combining like terms and using the Euler's formula to substitute out the, when you do the like terms, you will get a e raised to the negative j omega minus e to the j omega over 10 over 9 minus 2/3 cosine omega, and that's from the Euler's formula. From here, we're going to expand the denominator by FOILing it out. And then we use the double angle identity to simplify the cosine squared. From here, we just need to simplify the bottom slash denominator, and we obtain the final answer. There we go. I just want to stress that we work this one to show the importance of knowing how to get to a form of summation property to transform the summations out of the equation, and the need to manipulate the equation to use the Euler's formula and your trig. All right, thank you for watching.